where we started similar and congruent shapes. Now, similar and congruent shapes still fall under our topic of 2D geometry. Next week, when you log in on Monday, you're going to see that we're going to be starting transformations, and that's going to be our new topic next week, Monday. But tonight, we are finishing off with similar and congruent shapes. So we did have a look at this on Monday, and we started looking at some definitions of names. But what we're going to start with tonight is we're actually going to start with some terms that you might need to know before we actually dive into the work. Okay, so have your pen and have your paper ready, your highlighters, your ruler, your everything you need. We are going to get going. I see that I do have a hand raised, and I'm going to answer that question before we start. And Pilo, what is your question?
Hi, ma'am.
Hi.
How are you?
Good, and you, Mpilo?
I'm good, ma'am. I wanted to ask that would you be able to send Monday's work, because on Monday I didn't join.
Okay, thanks, Mpilo. All right, so Monday's lesson is actually available on YouTube, Mpilo, and what I'll do, Mr. Hugo has put the link for Monday's work, for Monday's lesson in the chat, okay, but I'm sure he'll put it there again for you. If you send him a message, he'll send it to you again. All right, so Mr. Hugo does have the link there. You can go onto Mpilo onto YouTube, or you can go onto a Watobe site, and you can get all the work from Monday. Okay. All right.
I did just send the link to Mpilo personally again as well.
Thank you so much, Mr. Hugo. And Mpilo, I hope that you've got that link and you can go back and you can check out Monday's class and make sure that you are all caught up to us. So, similar and congruent shapes, let's get going. Let's go make some notes. Okay, so we spoke on Monday about what the difference between similarity and congruency is, but let's go from the top. So the first one I'm looking at is I want to look at similarity. So on Monday, I said to you that similarity, when I think of similarity, I think of it being kind of the same. Okay, so in similarity, the shapes are kind of the same. Okay, what do I mean by that? What do I mean kind of the same? Okay, it means that if I had to go and draw a shape, such as, let's use this lovely one over here. All right, so here is my shape that I'm drawing. Okay, I've got some angles in that shape. So here is an angle here, angle A, and angle B. All right, and let's say that this bottom line over here, which is, we will call it AB, let's say that that measures 2 centimeters. Okay, and then because this is a semicircle, I'll say that this line on the top measures, I don't know, let's say from there to there, that this measures 8 centimeters. Okay, so there's my original shape. It's like a semicircle kind of shape. I've got angle A and I've got angle B inside of that shape. All right. I've got that bottom line that's 2 centimeters and the top part, the arc of that semicircle, which is 8 centimeters. So what it means when shapes are similar are the following. If I had to take that exact shape, okay, and I had to clone it like you saw that I did on my screen, all right, and now what I'm going to do is I'm going to go and enlarge that shape first. So I'm taking that shape, it's exactly the same, okay? It's almost like I'm going to photocopy it and I'm just going to make it bigger. All right. So what I see now in this new shape, okay, is I can see that the new shape, this is marked C and this is marked D. All right. I've still got angle A and angle B. Now you should be saying to me, ma'am, how is that possible? How come the angles are the same size? Well, guys, I'm going to show you how it's possible. If I take my little shape over here, and I'm just going to move them over, you'll see that, look at that angle. Can you see that that angle fits perfectly on that shape? So it's exactly the same. And if I move him to this side, that angle fits exactly the same and it's the exact same size. Okay, so in other words, the size of the angles have not changed. The size of those angles have not changed. I'm going to put them on here for you again. All right. What we call the corresponding angle, so how the shape fits in, will mean that angle A, it'll mean that angle A and angle B are the exact same size. All right. So first thing that we can say about similarity or similar figures is that, okay, what we call the corresponding, all right, and what corresponding means is like the picture of the other image, the picture of the other image, the corresponding angles. So the corresponding angles, which means that they are in the same position, you could say, the corresponding angles, so the angles which are in the same position are equal. So my angles are going to be equal. They're going to measure the same. All right. What's different here, okay, what's different here is you would see the following. In our first diagram, AB was 2 centimeters. In this diagram here, we're going to say that this bottom line is going to read 8 centimeters. So the corresponding side, okay, to AB, the corresponding side would be CD. And what can we see about CD? Are the sizes of those sides the same? No, they're not the same. What can we see? What did we do just now? What did I do on my page? I made that image bigger. Okay, so I'm going to say instead that the corresponding sides, so that means the sides that are in the same position, all right? And what we say is that they are in proportion. Oh my gosh, ma'am, what does that mean? What does in proportion mean? Well, if I had to take 2, what do I do to 2 to get it to 8? What do I multiply 2 by to get it to 8? Okay, I need to multiply 2. All right, let's grab my other pen here. I would say 2 times by 4 gives me 8, okay? Okay, so to get from 2 centimeters, all right, all the way to 8 centimeters, right? What did I do to 2 to get it become 8? I multiplied it by 4. So now, if I'm looking at my drawing, that means that this side was 8 centimeters. This big side on the top was 8 centimeters. So 8 times by 4 is going to give me 32 centimeters. What does that mean? That means that the sides are in proportion. In other words, to get from 2 to 8, we multiplied by 4. 8 times 4 gives me 32. So the corresponding sides of a drawing that are similar are in proportion. Okay. All right. Let's give ourselves a little bit of a note about what in proportion means. In proportion means when the ratios, so what we multiply by, are equal. Okay, when the ratios are equal. All right. two other words that you need to know before we carry on here. Two other words that you need to know. The first word that you need to know is what we call an enlargement. Okay, and an enlargement is the enlargement, the figure or the shape, the figure stays the same. So the actual figure stays the same, but the measurements of the sides increases. So the figure stays the same, but the measurement of the sides increases. So that's exactly what we did, okay? That's exactly what we did. What did we do? We saw that this small figure became this big figure. How did it become the big figure? Because what did we do? We multiplied it by 4. We multiplied it by 4, okay, to get it to become bigger. Now, will we always multiply it by 4? No, sometimes we'll multiply it by 2 to make it twice as big. Sometimes we'll multiply it by 10 to make it 10 times as big. But the actual figure, guys, is not going to lose its shape, all right? All that's going to change is the size of the sides, the measurement of the sides. All right. So there we did a enlargement. What's going to happen with a reduction? Well, for a reduction, the figure stays the same, but the measurements of the sides decreases. Okay, so let's go have a look at what a reduction would look like. So when we go reduction, we're going to make it smaller. So with reduction, what are we doing? Reduction, we're making a drawing smaller. So I'm going to go and pick a drawing, one of my shapes here. Let's pick this heart. So here is my original shape. There is my original shape. Okay, and let's give it a little heading there. Original. All right. If I want to show what a reduction would be, I'm taking my drawing, I'm cloning it. So it's exactly the same for now. I'm cloning it, and reduction means that I'm going to make the shape smaller. So there is my new smaller shape. Okay, so there is my reduction. All right. If I had to take my reduction, guys, so if I had to go and take my shape that I've reduced and I put it over this shape on the angle, look at the angles. The angles are all the same. So all the angles fit into each other. There's 2 angles in this little drawing, and the angles fit into each other. What has changed? So the shape of has not changed of the figure, right? What has changed is the actual measurement of the sides that's changed. Okay. I see that I have a question here. I think I pronounce it Lunka. Lunka, do you have a question for me? You should be able to unmute. Hi.
Hello, ma'am.
Can you pronounce your name properly for me so I can say it properly?
If you can't pronounce my name, you can just call me Lulu, because some people really find it hard to pronounce it.
Okay, well, tell me how you pronounce it though anyway. Let's hear it.
Lungutu.
Oh, Lungutu. Oh, it's beautiful. Okay. Tell me, what is your question?
Is reduction like the smaller version of the original or what?
Exactly. It's the smaller, it's the reduced version. Exactly. Well done. It's the smaller version of the original. That's a good way to think of it.
Thank you, ma'am.
You're welcome. All right, guys. So I see I have a number of messages asking me if I can scroll up and so that you can see the rest of the notes. So what I'm actually going to do is I'm going to do the following for you. I'm going to make them a little bit smaller. All right, and so now if you want to take a screenshot, you can, or if you're still taking a notes, hopefully you can see the screen, but if you want to take a screenshot of that, you can. Nzalo, do you want to ask me a question?
Hi, ma'am. How are you?
Good, thanks, and yourself.
I'm good. I'm sorry to disturb, but then can you please go back to the first example? I didn't quite understand.
No problem, there it is on the screen. So the one that was 2 centimeters and we enlarged it and made it 8 centimeters. Okay, what's confusing you?
Like the whole thing, I think when it comes to the measurements, the 32
The
centimeters.
measurement. Okay,
Yes, ma'am.
so all that it means is that, all right, previously in my original shape, the bottom line was 2 centimeters, okay? And the top line was 8 centimeters. But when I make this shape bigger, I'm making the shape bigger in proportion to the other shape, all right? So that means that whatever I do to one side, I must do to the other side. Does that make sense? Whatever I do to one side, I must do to the other side.
Yes, ma'am.
Okay, so on the bottom, do you see that to get from 2 to 8, what do I do to get from 2 centimeters to 8 centimeters? What do I multiply 2 by?
By 4.
By 4, good. So, to get from 2 to 8, I must multiply by 4. Whoopsie, our pen's not very happy with us tonight. Let's let it zoom out. Okay, so to get from 2 to 4, I need to multiply by 8, okay? And multiply by 4. So 2 times by 4. Oh, my pen is really not working with us. Let's try a different pen. So 2 centimeters times by 4 centimeters gives us 8 centimeters. Now, Nzalo, all that means is that it has to be done in proportion. So if originally the side was 8 centimeters, whatever I do to the one side, I must do to the other side. So what must I multiply 8 by?
8 by 4.
8 by 4, good. So 8 times by 4, what does 8 times 4 give me?
32.
32. And so the new size is going to be 32. That's all that it means.
Okay, thank you, ma'am.
You're welcome, Nzalo. No problem. All right, guys, just a reminder that if you do have any other questions, please can you make sure that you send them in the chat. I'm not going to get to answer all the questions tonight, otherwise we won't be able to get through the work that we've got planned. Okay, so that's similarity. I hope that you've managed to take a screenshot of that, or you managed to keep up with the notes, but there it is. Let's go have a look now at the next concept. And the next concept that we have to do is congruency. So now we're going to look at what we call congruency. Okay, congruency. All right, now what does congruency mean? On Monday, I told you that congruency means exactly the same. Exactly the same. Okay, so let's go draw 2 shapes for ourselves so we can see what I mean. I'm gonna pick let's pick a rhombus. All right, so here is my original rhombus. All right, I'm gonna call this original rhombus A, B, C, and D, going in alphabetical order and going all the way around the shape. So I've got angle A, B, C, and D. All right, I'm going to tell you that this angle here is angle A. This angle here is little angle B. This angle here is little angle C. And that angle there is little angle C. Okay. Because this is a rhombus, what does that mean? It means that all the sides are equal. Okay, so all the sides are equal. So in my rhombus, I'm going to say that this is 4 centimeters, this is 4 centimeters, this is 4 centimeters, and this is 4 centimeters. So there is my original shape, rhombus, ABCD, okay? All the sides are 4 centimeters. I've got the angles labeled, and now we're going to go and have a look. What does it mean if I have a congruent shape? So just like I said to you, congruent means exactly the same. In other words, I'm taking this original rhombus and I'm cloning him for you. And all it means is that maybe, oopsie, sorry guys, maybe what they've done is they've put the rhombus like that. Okay, so if they've gone and they've put the rhombus like that, is it really a big train smash? Not really. Okay, how are we going to tell whether these shapes are congruent? Well, first of all, we could take like a pair of scissors and we could cut the two shapes out and place them on top of each other to see that they are the same. But now that we're in grade 7, we can do some geometry to do that. So we're going to say that our new shape is MNOP. It's still got angles, so here are the angles. All right, but this angle here is still the same size as angle A. This one here is still the same size as angle B, still the same size as angle C, and still the same size as angle D. All right. Now, if that's true and they're exactly the same, guys, if the shapes are exactly the same, what else do I know? All right, in similarity, the sides are in proportion. Okay, so in similarity, the sides are in proportion. But now that they are exactly the same, okay, now that they are exactly the same, what is going to happen? It means that the original side was 4 centimeters, so this side is also going to be 4 centimeters. And this side is also going to be 4 centimeters, 4 centimeters, and 4 centimeters. Okay, so if I have a congruent shape, what does the word congruent mean? All right, congruent means that the two figures have the same shape and their sides have the same size. Okay, so if they're congruent, they're exactly the same. Okay, what we can say then about it is that we have incongruent shapes. We're going to have congruent sides. Okay, that means that the sides of two figures have the same length. All right, and what else do we have? We also have congruent angles. All right, and what do congruent angles mean? It means that the angles of two figures are the same size. All right, so I'm going to make that a bit smaller for you guys. All right, and I am going to answer some questions for you. Okay, so Olorato, do you have a question for me?
No, ma'am. I asked Mr. Hugo. He told me what's going on.
Awesome, Olorato. I'm glad that you asked Mr. Hugo and he has been able to answer you. Umar, do you have a question for me? Okay, Umar seems to have disappeared off my screen. Let's try Mulalo. Do you have a question? Hi, Mulalo.
Hi,
Mulalo,
ma'am.
you are unmuted. Hi, how can I help?
Ma'am, I just wanted to ask, like, where are you? Because on my screen, it's like you're still drawing those the congruent the parallelograms.
The rhombuses. So maybe your screen
Yeah,
is
the
moving a little
rhombus.
bit slower. Let's just check in with Mr. Hugo quick, Mulalo, and check if the screen is checking in at the same time. It might just be your collection. I'm just going to mute you and just ask Mr. Hugo. Mr. Hugo, are the notes appearing on your page? Can you confirm for me?
Teacher Kirsty, the notes are all well on this side. Everything is good. I did advise Mulalo what to do in the chat.
Okay, thank you so much, Mr. Hugo. All right, guys, so I am pausing so that you can make some notes there or so that you can take a screenshot, whichever one that you might be doing, because I know that sometimes when I get going and I'm making notes, sometimes I might be going a little bit too fast for you guys. So let's slow down a little bit. Let's take a picture or let's take some notes. I'm going to answer some more questions. Umar, I see you are back with your hand up. Do you want to ask a question now?
Yes, ma'am.
What's up, Umar?
Ma'am, are we gonna answer some questions?
Umar, of course we're going to answer some questions. In the next section, we're moving on to our worksheet. You know, like we do every week, we're going to move on to our worksheet now and we're going to fill in the questions together. And I'm going to ask you guys for some help.
Thank you, ma'am.
You're welcome, Umar. All right, I'm going to answer one more question. I see I've got Grace here. Grace, do you have a question for me?
Yes, Miss, I do.
Sure, what's up?
Miss, I don't understand like congruence. Like, I don't understand how it works, Miss.
How it works. So all it means, Grace, is you've drawn one picture and you've pretty much cut it up with scissors. So like, here's my one picture. All right. Yeah, here's my one picture on the screen. All right.
Yes,
You've
Miss,
cut it
I
out
can
with
see
scissors. Do you
it.
see I've cut this one out with scissors? All right.
Yes.
And here's my other, let me do it in a different color for you so you can see it in a different color. Sorry. Okay. So here's my one picture. Here's my other picture. Do you see that it's slightly turned on its side? The two
Yes,
pictures I've cut
Miss.
out with scissors. All it
Yes.
means is that this yellow one, what makes it congruent is that I can go and fit it straight over this green one. Can you see?
Yes, Miss, I can.
Which means what? It means they are exactly the same. Hey? It means that when I
Yes.
cut them out and I stick them together, they are exactly the same. In other words, what do I know about shapes? I know that they have angles and I know that they have sides. So the yellow shape over here, it means that its sides are exactly the same as the green shapes. And it means that the angles are also exactly the same. That's all that congruent means. It means they're exactly the same. Can you see? Does it make sense, Grace? Grace, are you good? Does it make sense?
Yes, Miss, it does.
Okay,
Miss.
good.
Thank you for
Good.
helping.
That's fine. No problem. Thank you, Grace. All right, guys. I hope that you have those notes taken down. I hope that it helps. If you're still confused by congruency, go and draw some shapes that are exactly the same and stick them over each other. That really helps. Like I've just done now with Grace with my green little square and my yellow little square. So congruent means that they are exactly the same. Okay. All right. A reminder, I'm not going to be able to get to all of the questions. I will try just now to ask a few more questions, but in the meantime, please can you send your questions to Mr. Hugo in the chat, who will more than happily help you guys out. All right, so we have now completed our notes for this lesson. Let's go and have a look at our worksheet for tonight. So tonight, our little cat has glow-in-the-dark eyes. There he is in the corner. And what is he asking us tonight? All right, so I'm going to be taking questions so you can raise your hands. Shapes that are exactly the same in every way are, Lungawa, you were first. Lungawa, you're going to help me out with this first one.
Yes, ma'am.
Okay, Lungawa, shapes that are exactly the same in every way. Same angles, same sides. What are they called?
A congruent.
Well done, congruence. Oh, now you're going to make me spell this word, and you know my spelling is not great, eh? There we go, congruence. All right, thank you so much, Ngoa. Okay, let's have a look at our next one. Our next one says, if two objects have the same shape, okay, but they are different sizes. In other words, the size of their lengths of the shape are bigger or they are smaller, but they are in what do you call it, in proportion. Now I know that I have a whole lot of hands up here. A reminder that if you want to answer a question, you need to lift your hand up for me so I can see on my screen. I'm going to go to Jabulile because they had their hand up next. Jabulile, what's my answer for B going to be?
Ma'am, it means the shape is similar.
Well done, Jabulile. The shape is similar. Thank you. Thanks, Jabulile.
Okay, ma'am.
All right, let's have a look at the next one. So let's come over the side for you guys. Oh dear, lost my mouse. There we go. All right. So my next one that I need to look at is as follows. In congruent shapes, all corresponding sides, so that's the sides that are like equal to each other, whatever. Okay, so in congruent shapes, all corresponding sides are, Umar, what's my answer going to be? Umar? Amar, are you with me? I think maybe, Amar, that your mic might be not working tonight. So some people did answer me in the chat there. So I'm going to put here in congruent shapes, all corresponding sides are equal. In similar shapes, all corresponding, so in similar shapes, all corresponding what are going to be equal. So when they're similar, what is equal? All corresponding what? Let's go with Lyle. Hi, Lyle. Oh, Lyle was there and then Lyle was gone. Let's go with Christina. Christina,
Hi,
I did
ma'am.
miss one. Hi, you're going to help me answer both. Are you ready, Christina? So in congruent shapes, all the corresponding angles are what in congruent shapes? What do I know about the angles?
All angles are equal. Or not?
Well done.
Equal.
You are right. Equal. And then stay with me. In similar shapes, all corresponding what are equal?
It's
In similar shapes.
all corresponding sides.
Okay, careful. In similar shapes. So similar, what does similar mean? They're the same shape, but they might be a different size, hey?
Size.
So the sides aren't equal. The sides are in proportion. Remember, what are
So it's
equal? Though?
angles.
It's the angles. Well done, Christina. Okay, just be careful with that. Picture it for yourself. Like draw a little or like put a little triangle on your fingers and say, okay, that's a smaller one. That's a bigger one. So the sides can't be the same, but what can be the same is the angles.
Hi, ma'am.
Okay, thank you so much, Christina.
You're welcome.
All right. Okay. Oh, dear. Let's have a look at our next one. So in similar shapes, no corresponding, and Christina helped me out with that one already. So in similar shapes, no corresponding sides will be equal. What will they be instead? You guys have told me in the chat, you've said in proportion. So well done, everybody. Well done. Moving down to our next question. Oh my, there's a whole lot of different images here. I'm going to go and give this one a letter for you so you can see it nicely. This is letter K. All right, so there are a whole lot of shapes there for you. All right, let's move this down. And for A, what I'd like is I'd like you to give me 2 pairs of congruent shapes. So out of all those shapes there that are on your screen, can you tell me which ones you think would be congruent? Which ones do you think would be congruent? Okay, let's go with Mulalo. Your hand was up. Mulalo, which ones do you think are congruent?
Ma'am, I think A and J are
A
congruent.
and J. Okay, remember congruent means
No.
exactly the same. Yeah, I'm still with you.
C and K. C and K.
C and K, I am happy with those. I definitely agree with you. I would say two pairs of congruent shapes would definitely be letter C and letter K. In other words, if I had to cut them out, could I put them on top of each other? Yes, I can. All right, my next question. All right, it has asked me for two pairs. Let's see if we can see another one. Okay, thank you, Mulala, for that first one. Let's see if somebody else can give me another one. Let's go with Katlejo. Katlejo, can you see another pair of congruent shapes?
I think it's
It's kind of difficult, hey? Yeah?
I think
D and?
it's D and G.
You are amazing. Well done. I agree with you. D and G also look like they are congruent. Well done. Nice. Well
Thank you.
done. All right. Give two pairs of similar shapes. So ones that are like kind of the same. In other words, in proportion. All right. Who's going to give me my first pair? Let's go to Unati. Hi, Unati.
Hi, ma'am.
How are you?
Fine, and you?
I'm good, thanks. Right. Unati, can you give me two pairs of similar shapes?
I would think it's I and H.
Well done. A and H, I think H looks like it's a bit skewed. Can you maybe see a letter that's near H that looks kind of more similar to A? I definitely
E.
agree A. I would say A and what about J? Look at this little one over here, J. I'm going to go and highlight him for you quick. Look at him. All right, so look at J. Doesn't he look like he's much smaller than if we had to look at, oh, doesn't want to work, sorry. Okay, so he looks like he's much smaller than if we looked at A. Okay, so definitely A and J. Are you happy with those?
Yes, ma'am.
Thanks, Sonati. All right, let's see if somebody else can help me out with another pair. Let's go with Bushle. Bushle? Hi, Bushle.
Hi, ma'am. I think it's
Hi.
B and F.
Well done. Definitely agree with you. I would probably say B. Oh my goodness, my pens are changing color. I would also say B and F. Well done. But it is kind of difficult when we just have joints, but well done. That's amazing. Well done. Thank you, Bushle. All right, moving on. How many, this is a nice test. How many quadrilaterals can you see in the drawing? How many quadrilaterals are there? Quadrilaterals. So first, I'm going to ask Riri to tell me what a quadrilateral is. Oh, Riri, you disappeared from my screen. Oh, people are just disappearing tonight. Let's go with Christian. Christian, how many quadrilaterals? First of all, what is a quadrilateral?
A quadrilateral is a shape that has four sides. Four sides.
Okay, 4 sides. Well done. Good, Christian. How many quadrilaterals
All
do
of
you
the
see on the
sides
screen?
are equal.
All the sides, okay. And how many quadrilaterals do you see on the screen?
I see B and F.
I agree with you. B, F. Remember, for a quadrilateral, the sides don't have to be the same. Hey, there just has to be 4 sides.
Maybe
So
I
how
can say
many do
D
you
and
see? B, good. Okay, so we've got B. I agree. I've got D as a quadrilateral. What about F? Is F a quadrilateral?
Yes, also F.
And what about G?
Yes.
Well done. So I've got B, D, F, and I've got G. Thank you so much, Christian.
You're welcome, ma'am.
All right. Mr. Hugo, I'm not able to mute Christian. Oh, thank you, Mr. Hugo. Okay. So let us have a look at our next question. So our next question says to us, oh dear, sorry guys. So our next question says, how many triangles do we have above? So triangles have 3 sides. And if I'm looking at my drawing and I'm looking for the triangles, I see 1, 2, 3, 4, 5, 6 triangles. So how many triangles do I see? I see 6. All right. How many right angle triangles do we see above? So how would we measure a right angle triangle? Tell me in the chat. How would we measure a right angle triangle? What maths tool should we use to measure a right angle triangle, guys? What's the maths tool? Measure with a protractor. Well done. And there are definitely 2 right angle triangles. If we go have a look at which ones those right angle triangles are. Oh, actually, yeah, no, I agree with you too. I can see that if I had to take my protractor out and measure them, then I would say that this is a right angle triangle and a nice little one over here is a right angle triangle. Okay, well done. All right. How many scalene triangles are there above? So what does scalene mean? It means that all the sides are different lengths. All the sides are different lengths. And I am definitely seeing for my scalene triangle, okay, I'm going to go count them off for you. So that's definitely not a scalene. That looks like a equilateral. This triangle looks like an isosceles. Would E be a scalene? I would say E is kind of like a scalene. Would H be a scalene? I would agree and say H looks like a scalene. J is definitely not, and K also definitely not. So I'm going to say 2. How many parallelograms do we see above? Well, if I'm looking at parallelograms, remember parallelograms, 4 equal sides and opposite pairs of sides that are equal, all right? So I can definitely see 1, 2, 3 parallelograms, because remember a square is also a oh, hold on, I'm lying to you, 4 parallelograms. Remember that a square is also classified as a parallelogram. And finally, how many squares do we see above? I see 2 squares. All right, grade 7s, that brings us to the end of our lesson tonight. All right, I know it went by so super quick.